Okay, so welcome, and now we're going to do an example of sketching a period of a general tangent function. So now, notice the first thing that you notice is this is already in the form that we wanted it. Okay, so we can easily pick out what A, B, C, and D are. Okay, so let's get started. So now that we have it in that form, the first thing is notice that, the next thing is notice that A, right, the stretching factor is -2. So A equals -2, okay? Now, also, the next thing is to talk about is B, right? So B is pi, which tells us then the period is going to be what? The period is what? Pi over the absolute value of B, which equals, in this case, it's pi, so pi over pi, so the period is 1. Okay, now, C, what is C? C is -pi. Why? Because again, we have a subtraction here, so this is going to be -pi. So C is -pi, which means the phase shift, right? So that tells us the phase shift is equal to B over C. Or excuse me, C over B. Which is going to be what? -pi over pi, which equals -1. Okay? And now, what else can we say? Well, the asymptotes. Okay, so we need to know the asymptotes. Okay, and we also need to know that it's shifted. So let's sketch the graph. We'll do it right here. Okay, so we're just going to do one period. Okay, so the way I'm going to do it, I'm just going to sketch one period. Okay, so now, this is phase shift, right? So the phase shift is -1. So that means this would normally start at the origin, right? Well, it's now going to start what? It's going to start 1 unit to the right. Okay. Or no, 1 unit to the left. Right? So it's going to be 1 unit to the left. So the phase shift is telling you what direction. But you can also see it because remember, just show you something. Remember, just like before, to see the phase shift, you want to write this as what? You factor out the pi, right? Factor out the pi, factor out B, in other words, you get pi times what? You get x plus 1. And so then here, the 1, you're adding 1 to x, which means you're going to move to the left 1 unit. And so the phase shift, -1, 1 unit to the left. So these match. These should always tell you the same thing. Okay, so we're going to move 1 unit to the left. So let's say this is 0, right? So this is 0. Let's do 0, -1, -2. Okay, so it's going to go through -1. Okay, that's good. Okay, now what else do we know? It's being shifted down 1 unit, so that means how do I want to write this? So this is 0. Let's go here. Okay, and let's do like so. And now we're going to shift down 1 unit. So now we know it's going to go through that point. So the origin, right, it usually goes to the origin, but now it's being shifted to the left 1 unit and down 1 unit based on this. Okay, and the period is 1, right? And so since the period is 1, that means what? The asymptotes are going to be located where? One half of that, so or C over B plus 1/2 of that right? So C over B plus 1/2 of that. So remember, it's going to be, the asymptotes are going to be located at x equals C over B plus what? Pi over the absolute value of B, right? Let's change that. Okay? Times odd integers of k. So these are going to be multiples of this. So it's going to be this plus this. Well, pi over 2 times b is 1/2 of that, right? Because it's pi over the absolute value of b, we know is the period. So it's always half the period. So it's going to be wherever this is, right? Which is -1, that's the phase shift, right? Plus a multiple, any multiple of this. So that means we're going to be going to the left and the right 1/2. So that means we're going to have the asymptotes are located here. So I'm going to draw these. Okay. Now we're pretty much almost done. And then we want to plot any 3 reference points. Well, we got 1, right? So we got 1. And so we want to get another one, or 2 more. So let's do this. Okay, so if this is 0, well, we don't want to do that one. When x is 0, let's see, if x is 3, let's go halfway. Oh yeah. Let's do that. Look. Why don't we do halfway, just like before? We could cut this up into quarters, right? So let's do, this is 0.5, or negative 0.5, so let's do negative 0.75 and do negative 1.25. Okay? Let's do the negative 1.2, negative 0.75. Well, if we do, which is 3/4, right? Negative 3/4, right? If this is negative 3/4, what happens? Well, this is 3 pi over, this is negative 3 pi over 4 plus pi. So what happens? So I get negative 3 pi over 4 plus pi gives you what? So this would be what? 3 pi over 4, negative 3 pi over 4 plus 4 pi over 4, which gives you a positive what? Pi over 4. And so what do you get for the tangent of pi over 4? It's going to be 1. And so this becomes 1. This becomes negative 2 minus 1 gives you a negative 3. Now, so that's going to mean that negative, if I'm here, right, so I'm going to be halfway here, so this is going to be at a quarter. This is negative 0.35. I'm going to be down here. Let's say negative 3. So this is going to be, oops, wrong way. Wrong, a little too far over. Like that. Now this is going to be a reflection around here. This is where the normal inflection point is, right? So it's going to go through here. It's going to go start going up. So if I'm 3 units, if I'm down to negative 3 here, that's going to be 2 units from where I started, where the inflection point is for the tangent function. So if I'm going to be 2 units down from here, I'm going to, over here at negative 1.25, I'm going to be 2 units up. So that means I'm going to be at positive 1 here. So that means that my it's going to start here. Now look, so it's going to do this. Like that. Oh, and that makes sense because guess what? This is negative, which means it's inverted, right? So it's inverted here. And there it is. That's the graph. Have a great day.